Hello everyone, welcome to School of Dapps. On this channel, we transform aspiring developers into skilled blockchain experts. If that's what you want, don't forget to smash that subscribe button and turn on notification so that you don't miss any of our deep dives. The Solidity team has released new version of Solidity compiler version 0.8.29. This update includes some big changes, especially in the way smart contracts are compiled and stored on the blockchain. In today's video, we are going to explore the major update in this new version. Now, don't worry if that sounds complicated at first. As always, I am going to break it down into simple terms that even if you are new to Solidity or smart contract development, you will walk away understanding why this matter and how it's going to change the way we write Solidity smart contracts. The Solidity compiler version 0.8.29 brings new experimental features and improvement. This version includes features like experimental support for EVM Object Format, EOF. Secondly, custom layouts. And thirdly, initial support for ethdebug. Ethdebug is a new debugging format for smart contract in Solidity. Now let's look at the EVM Object Format, which is also referred to as EOF. If the word is new to you, you might be wondering, what does this mean? Imagine the Ethereum virtual machine, the EVM, as a kind of operating system that runs our smart contract. But to do that, it doesn't understand Solidity directly, so it needs to read it in a bytecode, a low-level format generated when Solidity code gets compiled. Up to this time, Ethereum has used a pretty raw, unstructured format to store and execute this bytecode. It works, but it is messy, hard to upgrade, and can lead to weird errors like stack too deep. And that's where EOF comes in. EOF is a new structure for how smart contracts are represented in the EVM. Think of it like switching from a messy handwriting note to a neatly formatted document with sections. EOF brings a whole new format to how contracts are deployed and executed. With EOF, a contract bytecode is divided into clear sections. A header that defines what kind of contract it is and the version. Secondly, a code section where your executable logic lives. Then thirdly, the data sections for constant value. We also have the metadata sections, and possibly there will be more in the future. This reminds me of the structure of Solana architecture where data is stored in a separate account. This makes contracts way easier to analyze, safer to execute, and more predictable for tooling. EOF introduces opcodes that helps us avoid one of the most annoying issues in Solidity smart contract development, which is stack too deep. If you have ever tried writing a smart contract of any complexity, you must have probably run into this error. This new opcode, like the swamp and the dump, allow deeper and more flexible manipulations of the EVM stack, reducing the chances of these issues entirely. This is going to hugely improve the developer experience and reduce the need for weird refactoring streak. Under EOF, the EVM will now refuse to execute certain bytecode that doesn't conform to this structure. That means fewer vulnerability and more predictable behavior. It also blocks some low-level edge cases that previously could be exploited or led to unexpected behavior. The EOF structure makes the EVM more efficient. That means you have lower gas cost, we have fast execution, and more optimized contract size because the EVM can now pass your smart contract faster and with more accuracy. One of the hidden power of the EOF is that it's future-proof. Right now, adding new features to the current EVM is hard because of the backward compatibility. But with EOF, we now have version sections with bytecode. So when Ethereum wants to add a new features down the line, it can do so without breaking the older contract. One thing to note is that the EOF is still experimental. You can only use it if you compile for Osika, which is the future Ethereum upgrade, not yet on mainnet. This is more for forward-thinking developers who wants to start testing and giving feedback. There are some things to take note of when using the EOF. You cannot use the gas left method anymore because it's disabled under the EOF. In deploying smart contract with new, you must now provide a sort, which is a unique identity to generate the new address. Deployment and tooling behave differently, so be prepared for a few sharp edges while it is testing. EOF helps developers, Ethereum nodes, and users by making smart contracts smaller and more efficient, reducing gas cost by making execution faster, eliminating common code error like stack too deep, then making Ethereum easier to upgrade in the future. These are the benefits of EOF. Now, who gets to benefit from EOF? For the developer, writing smart contract becomes easier with fewer errors, while for the users, transaction becomes cheaper and faster, while for the Ethereum blockchain, it becomes more efficient and scalable. EOF is like upgrading from old and messy toolbox to a new and well-organized one. It helps Ethereum evolve by making smart contracts cleaner, safer, and more efficient. Secondly, outside of EOF features, this new version had some great stuff like the support for custom storage layouts. Before now, a Solidity smart contract stores data on the blockchain in a specific way. By default, Solidity assigns storage location automatically. This update allows developers to choose where their storage variables should be stored. This feature is helpful for account abstraction, which is a new Ethereum upgrade, EIP 7702. It lets smart contract act like a normal Ethereum account, which can improve security and efficiency. Developers can now manually set where storage variables are stored inside a smart contract. Okay, here is an example that we declared now called X will be stored in a memory location which is 2 raised to power 225 minus 42. This helps the developer who wants more control over their contract stores data. Well, this is just the beginning. In future updates, Solidity will allow even more customization for storage layouts. Thirdly, this version includes an initial support for ethdebug. Ethereum is slowly rolling out a new tools called ethdebug. These tools help us understand how our smart contract as developers runs at the opcode level. Right now, ethdebug only supports basic features like showing smart contract instruction and where each line of code is located. If you want to test this feature, you need to turn it on using the command line. We are turning it on using the command line double hyphen ethdebug. So this is how we turn it on using the command line. It's just the first step. In the future updates, ethdebug will become much more powerful. This new version also fixes a bunch of issues like cleaner errors message, stability fixed in inline assembly, better optimization when compiling. In summary of all what I've said so far and why it matters, EOF is more than just a formatting change. It's Ethereum evolving. This update sets the stage for safer, faster, and more future-proof smart contracts. Now remember, EOF introduces structure, safety, and better tooling. Serious about Solidity, now is the time to start experimenting with these features. Even though EOF isn't on mainnet yet, testing and understanding it now will give you a serious edge when it goes live. Head over to the official Solidity document and download the version 0.8.29. The link will be in the description below. Alright, that's it for this video, and if you have found this helpful, please don't forget to hit the like button, subscribe to the channel. Let me know in the comment below what features are you most excited about. Until next time, keep learning, stay ahead of the chain, and keep building the future. Signing off from us all at School of Dabs. See you in the next video.